Okay, constant acceleration. Main topics to be covered would be understanding and interpreting the displacement time graphs, velocity time graphs, and then using them to solve the problems and constant acceleration formula. So, prior knowledge which you should have is that straight line graph starting from origin, what does that mean? And area under the graph, what does it give depending on what is on the x-axis and y-axis. Then using simple formulas, solving of simultaneous equations, and so on. Before we start with this, let's have a basic knowledge of which graph gives what. So for example, we have a graph which is displacement against time. Second, we have velocity against time, whatever the shape of the graph is. And third, we have acceleration against time. Now there are two ways how we can do this with graph individually, or we can make a table. So if you see the symbol displacement time, velocity time, and acceleration time, when you come down from displacement to velocity, then velocity to acceleration, this is basically gradient, or you call it slope. And when we move from acceleration to velocity, or velocity to acceleration, displacement, that is area. So basically gradient of displacement time graph, compare these two. This gradient of displacement time graphs will give you velocity, and there is nothing above this displacement time graph, so area gives you nothing. Like displacement into time is nothing. When we come at velocity time graph, the gradient of this gives you the acceleration. So gradient equals acceleration, and area, when you go above it, that gives you the displacement. For the third part, whatever the shape of graph is, when we talk about the gradient, that gives you nothing because there is nothing below this point, or acceleration divided by time is not giving us anything. And area of this graph will give you the velocity. Acceleration into time is velocity. This is one way. The other is, if you need to understand, when we talk about the gradient of displacement time graph, the first one, so our basic equation is displacement equals velocity into time. So when we make velocity the subject, so you see this is change in y and this is change in x. So change in y over change in x is gradient, and that is actually giving you displacement over time, which is velocity. When we talk about the second graph, velocity time graph, if I talk about the gradient, that gives me acceleration. And how so? Acceleration is change in velocity over time taken by definition. So change in velocity over change in time. Now look at the axis. Change in velocity is on the y-axis. That is change in y, and change in time is on the x-axis. That is change in x. So y over x is again the gradient. And when we talk about the area under the graph, depending on the shape, we may have a rectangle or anything, but we are multiplying the two x's. So when we multiply velocity into time, we've already discussed that makes it displacement. In the third case, acceleration time, the gradient is giving you nothing. Acceleration over time is not giving you anything. But when you multiply these two, the two shapes, area into acceleration into time, so you see acceleration into time is actually change in velocity or velocity. Now, when we look at these shapes and graphs, displacement time graph. So, displacement time, velocity time, acceleration time. Gradient will give us the velocity. So, you see the gradient is 0. That means the velocity is 0. So, I can say the object is at rest. In the second half, I can see that gradient is constant. We don't have any numeric values on the axis, so let us talk in generic form that gradient is constant. And that means velocity is constant. So the object is moving with constant velocity. Or I can say the object is covering a distance at a constant rate. In the third case, if we draw the tangent to find the velocity, I see that the gradient is increasing. So when the gradient is increasing, we can say velocity is increasing. Basic formulas: average velocity is total displacement over total time. Average speed is total distance over total time. Question number 1. This is the displacement time graph for car traveling along a straight road. The journey is divided into 5 stages labeled A to E. A, B, C, D, E. All sections are straight lines. Work out the average velocity for each stage of the journey. So for each and every stage we have 5 stages. In the first stage, y-axis shows us the displacement. In the first stage, distance is 40 and the time is half hour. So for A, distance over time, my speed is 80 kilometers per hour. For B, the distance covered is rise over run. Distance covered is 20, and this one box actually represents half hour, so that is 40 kilometers per hour. Look at these values. We can also see it from the gradient, which is evident that from A to B the gradient is decreasing and hence the speed is decreasing, the velocity is decreasing. When we talk about C, no distance is covered in half an hour, so it is 0 kilometers an hour, and the object is at rest from 10:30 to 11:30 and the displacement is 60 kilometers. When we talk about D, these two boxes, they represent 40 kilometers in 1 hour, so the speed is 40 kilometers per hour. And if you compare B and D, we can also see that the gradient is same. Rise over run is 1 unit 1, 1 unit 1, 1 unit 1. In E part, displacement is actually decreasing, and that is negative 100 divided by 1.5 hour. So 100 by 1.5 is 200 by 3 or 66.7 kilometers per hour. As far as we are talking about velocity, we are concerned with positive and negative signs. B part says state the average velocity of whole journey. So whole journey is total displacement over total time. So it takes 100 kilometers away from mean position and then coming back. So 0. So 0 by whatever time is. So 9:30 to 13 is 4 hours. That's 0. C part says work out the average speed for whole journey. Now it is distance. So total distance. We took 100 kilometers away and 100 back. So 200 by 4 hours is 50 kilometers per hour average speed. Question number 2. Khalid drives from his home to hotel. He drives 2.5 hours at an average velocity of 60 kilometers per hour. Now something is missing on y-axis. He stops for lunch before continuing to his hotel. The diagram shows a displacement time graph for Khalid's journey. Work out the displacement from hotel to Khalid's home. So he's actually traveling at 60 kilometers an hour. So I can see that in 1 hour he should have traveled 60 kilometers right here. And this straight line is actually till 2.5 hours. So distance is equals to velocity, displacement equal velocity into time. Velocity is 60, time is 2.5. So 60 times 2.5, this is 150. So we have these x's, and if I just break it down into 1, 2, 3, 4, 5, 6, 6 equal boxes, so one box would represent 25 kilometers on y-axis. So work out the displacement of hotel from Khalid's home, that is 150. Khalid drives from home to hotel. Sorry? Yeah, just checking that. Khalid drives from his home to hotel. He drives for 2.5 hours at an average speed of 60. From home to hotel in 2.5 hours. So that's home and that's hotel. He then stops for lunch before continuing to hotel. So this is not it. He stops here and the diagram shows the displacement time graph, and then he covers the remaining distance again. So this is another 25, that makes it 150 plus 25 is 175, and this is half of it, that is 12.5 plus 12.5 makes it 187.5. So work out the displacement of hotel, that is 187.5 kilometers from home. Work out Khalid's, is that clear? 187.5. B part says work out Khalid's average velocity for his whole journey. So total displacement over total time. Total displacement is 187.5 and time right here is 3.75. So 187.5 divided by 3.75 is 50 kilometers per hour. So Sarah left home at 10 and cycled north in a straight line. The diagram shows the displacement time graph for her journey. Work out Sarah's velocity between 10 and 11. So we see the graph. Velocity is given by the gradient between 10 and 11. Base is 1 and the height is 12. So gradient is 12 by 1. Velocity is 12 kilometers per hour. On her return journey, Sarah continues past her home for 3 kilometers before returning. So she is returning and she passes her home for 3 kilometers. This point right here. Before returning, estimate the time that Sarah passes her home. So this is the point where she crosses, which is at 13, and she started at this point, which was 11:30, and we have to estimate this time. I am very sure about these two coordinates, which are on x-axis this is 11.5, on y-axis that is a 12, and this point right here on x-axis is 13, and on y-axis is -3, which is given in the question. Now one thing is for sure, that this point right here on x-axis we take it as unknown and y as 0. Now we call them collinear points. These 3 points are on one line, so all these should have same gradient. So if I use these two and write y2 minus y1, taking this as the second point, over x2 minus x1 should give me the gradient of this line, and if I equate it with gradient of these two, that is y2 minus y1 over x2 minus x1 to find x. I'm using my calculator And minus 3 minus 12 by 13 minus 11.5 gives me negative 10. So negative 10 is equals to negative 12 by x minus 11.5. Cancel out these two. Then we cross multiply. X minus 11.5 is equals to 1.2 and x is equals to 1.2 plus 11.5 gives me 12.7. Now this point right here is 12.7. Let me just write and then we'll convert it back. This is 12.7. Now I'm going to convert this 0.7 into minutes. So that is 12 hours, and 0.7 into 60 gives me 42. So 12:42 is this point when she crosses her home. Clear? C part. Work out Sarah's velocity for each of the last two stages of her journey. So velocity is the gradient. We've already done in the second last part for this section, that is minus 10. And for the last section, we know the time, it ends at 14. So 14 minus 12.7 gives us 1.3 hours, and she's covering 3 kilometers. So distance over time, 3 by 1.3 is 30 by 13 or 2.3 kilometers per hour. D part. Calculate Sarah's average speed for her entire journey. So average speed is total distance divided by total time. So she covers 12 moving away, then 12 and 3 15, then 3 again. So 12 plus 15 plus 3 is 30. Total distance is 30 and total time from 10 to 14 is 4. And 30 by 4 is 7.5.